All right, so back for number 4 here. So let's got a temperature equation. So time 0 boiled potatoes taken from a pot on the stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius t equals 0. The internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h satisfies that differential equation where h of t is measured in degrees Celsius. So this equation right here is the rate of change of the temperature of the potato. So it says write an equation for the line tangent to the graph of h at t equals 0. So if I'm going to write an equation of a tangent line, as always, I need a point and a slope. The point is 0, and it says that's 91. And then the slope, I just need to plug a 91 because that's this. These are t comma h. So I plug a 91 into this equation. So if I do that, I get negative 1/4 times 91 minus 27, which is what, 64. So 1/4 negative 16. So then I write an equation. So I get y minus 91 equals negative 16 times x minus 0. So I get y equals 91 minus 16x, and that should probably be a 16t to be accurate, but that's fine. B says use the second derivative to determine whether your answer is an underestimate or an overestimate. Okay, so if I have the first derivative here, I'm going to distribute the negative 1/4. So I'll get negative 1/4 h plus 27/4. If I take the derivative of that, now remember all of these derivatives are with respect to time. So this will be negative 1/4, and that'll be dh dt. And we already know what dh dt is equal to, so I'll do negative 1/4 times negative 1/4 times h minus 27. Negative 1/4 is 1/16, which is positive, h minus 27. So this is always positive, which means we are concave up. The reason this is positive because it said the temperature has to be greater than 27, so we get positive, positive. If we think about a concave up graph, and we draw equation, or we draw a tangent line, and we use a tangent line value to estimate a value. Oh, sorry, I never did when t equals 3 up here. So if I finish this, I do 91 times 60 minus 3, which is 48, so 43. So my estimate is 43 degrees Celsius at time t equals 3. So then my guess is this an overestimate or an underestimate? Well, if I'm concave up, then my line guesses are going to be underestimate. So I would say that is an underestimate because we are concave up. Part C says, an alternate model gives this one here. It says where g of t is measured in degrees and g of 0 equals 91. Find an expression for g of t based on the model. What is the internal temperature? Okay, so I have dg dt equals negative g minus 27 to the 2/3. So when it says find an equation g, that means I need to separate variables. So I'm not going to take that negative, but I'm going to take this over here, and over here would be g minus 27 to the negative 2/3, or 1 over g minus 27 to the 2/3 dg equals negative 1 dt, and then I'm allowed to integrate. So let's think about this. If I'm going to add 1 to this power, that means I'm going to get g minus 27 to the 1/3. So if I did this, I'd get 1/3 times all of this to the negative 2/3 times the derivative of the inside. We're now just in terms of one variable here, so just 1. So I don't want a 1/3, so I'll put a 3 over here. And then over here I get negative t, and remember we'll do plus c, but just on the right. Now if I'm going to solve here, so I would probably use my initial value right now to find c. So it says at time 0 the temperature is 91, so if I put a 0 in here I get a 91 here, so I get 3 times, what do we say, 64 to the 1/3 equals c. Well, 64 to the 1/3, cube root of 64 would be 4, and 4 times 3 is 12, so my new equation is 3 times g minus 27 to the 1/3 equals negative t plus 12. Now, if you want to wait till the end to find that c value, that's fine, but one of your points will always be for doing that. So now, if I were to divide everybody by 3, I get g minus 27 equals negative 1/3 t plus 4. And then if I were to, sorry, I still have 1/3. If I were to cube both sides, I'd get g minus 27 equals negative 1/3 t plus 4 to the third. And if I were to then add 27, I would get g equals negative 1/3 t plus 4 to the third plus 27. Okay, and then they asked me to use that to estimate the temperature at time t equals 3. So if I plug a 3 into here, 3 here gives me negative 1 plus 4 is 3 to the third is 27. So we end up getting 54 degrees Celsius at that time. Okay, so whenever we are asked to solve a separation of variables problem, so anytime we're given this premise, they're going to ask us to find h or find g, or this premise here, then a lot of times they say find a particular solution. We'll see that a number of times before we get to the test, but if you look at all the points that are available here, so if you separate variables, you get a point. If you take antiderivatives, you get a point. A lot of times you get 2 for this. If you have a plus c, you get a point if you use your initial condition, which means you ever plugged in the 0, 91 or whatever. If you have equation involving g and t, so literally if you have an equation that says g of t and then you get 1 for here, so you can see that's a boatload of points. So you want to make sure that you're on top of that if it's ever asking us to separate variables. There's a lot of points to be had here. Okay, I'll be back with number 5 soon.